guess we're up.
Yay!
Hey!
Somebody had to.
Somebody had to. And it had to be you.
Better late than never.
Better late than never.
Yeah.
Okay. Hey, good evening, all. Are we good on YouTube? Yes. Not seeing anybody joining in yet, but it looks like we got a few here on Facebook.
All kinds.
All kinds on Facebook, and here come a couple from YouTube. There we go. Okay, we're all set. Hey, hello, everyone, and welcome to our Sunday night offering of Astronomy Outreach for July the 3rd. The Sunday Night Astronomy Show. Yay!
Yay! You gotta get both hands up. Kermit did this, right?
He did. My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I'm an amateur astronomer, a member of the Royal Astronomical Society of Canada.
Yay!
Hey! We got Paul on here from the UK. Hey, Paul. Good to see you. First of all, I'd like to welcome back my two regular co-hosts, fellow RAS member, Mr. Mike Powell from the PFO Observatory here in St. John. Welcome, Mike.
Oh.
Hey, PFO. And I'd like to welcome back our other regular co-host, of course, and fellow RAS member, Mr. Paul Owen from the Moon Shadow Observatory in beautiful Hampton, NB.
It is.
It is. Okay, anyway. All right, on tonight's episode.
Muppets theme going. What do you think?
No, yeah, better
That's
not.
kind of what we do
Better
when
not.
we start.
I just want to sing. See, that's my problem.
Well, you two are the old guys up on the balcony.
Oh, yeah.
Speak for yourself.
Steldorf or something? I don't know.
I don't know.
Maybe somebody can tell
Anyway,
us.
I know what you mean.
I know you.
Nose like this, I'm more like Gonzo anyway.
Okay, on tonight's episode of the Sunday Night Astronomy Show, when was the last time you looked up in wonder? The summer night sky presents a wealth of deep sky treasures to enjoy, from recognizing the beauty of our place in the Milky Way to learning about distant celestial targets. A night under the summer sky full of stars will leave you in awe. Right, guys?
Oh.
Awe. Awe.
Wow.
Oh.
Tonight in our discussion segment, we'll reveal our top 9 naked eye, binocular, summer sky treasures. Say we're top 9. That's kind of cool.
Top 9.
And we'd love to hear from you as well. If you have like your favorites, put them in our comments here, you folks on YouTube and Facebook. Let us know what your favorites are. Also tonight, Mike will be giving us another method to save astronomy dollars in his Mike Guyver segment. Hooray! Bino Bud has promised to return as well with another timely binocular target of the week. And Paul will be delivering another interesting episode of Rosanna's Fun Facts, and he has another idea to share with us in his astrophotography tip of the week.
Mm-hmm.
Sounds good.
Yeah.
I'm going to offer a quick view of what to look for in our sky this week. Not a whole lot happening, but good to talk about what is happening anyway. Good thing we got a moon.
Yeah.
Yeah, we had a couple of moons that have more to talk about, but
True.
there it is, Statler and Waldorf. Thank you.
Aaron Waldorf, that's it.
That's it. And I'll also have all of your wonderful photo submissions to share. So another busy show, guys. So this is a family-friendly, interactive live broadcast. So for those of you joining us from my YouTube channel or my Facebook page, we are happy to try and answer all of your astronomy questions here in real time as well. And of course, we'd like to welcome back all of those who have been joining us through the local Rogers TV network. Thank you for your support.
Yes.
Appreciate it. So let's get started then, I guess, guys, with our tonight's program and our top 9 summertime naked eye and binocular targets. And the reason why we brought this up is because we are right now into the new moon has just passed. We're just into a couple of days of the waxing crescent. I think first quarter is Thursday. No, maybe Wednesday. Maybe no. I think it's in my stuff. Yeah, it's either Wednesday or Thursday. It's in my WhatsApp talk. Yeah. But anyway, we've got some days here that are going to afford us some, dark skies. And I think tomorrow night's clear and looks like it's not bad tonight. So these are the times to be out looking for those deep sky treasures when we got the Milky Way kind of popping over to our southern part of our sky earlier in the evening. Planets are going to be coming around shortly, but for now we've got these deep sky treasures to enjoy. So let's take a look at a few things that we can see. Here you go. With naked eye and binoculars. Mike is going to start us off. Or am I starting?
Nope.
Go ahead.
You are.
Oh, I was.
Yeah.
You're
Okay.
in dead end.
Oh, okay.
You're
Start
Canadian.
with the bay. What you see from the bay?
Did we say that? Okay. Okay, just give me a
How
second.
quickly we change our minds, eh?
Yeah, how quickly. Okay, I just got like a little bit of a. Yeah, let's take this up here. A little
That
bit of
way I can change
a.
mine before I get to it.
Yeah, nice. Just a bit of a slideshow. How I was going to present them. So we'll see what happens. Okay, so all I was going to talk about was the area around Sagittarius. I'll go from here, beginning. So Sagittarius, of course, is the archer in Greek mythology, but a lot of us had looked at the sky, and we had talked about doing this before, guys, just looking at the constellations and picking out the asterisms, which are kind of more familiar or easier to find, I'll say. So Sagittarius can really be nicknamed the teapot. So here's the spout over here. Well, of course, there's the lid, handle, spout, and coming out of the spout, all that steam is the Milky Way. Like diamonds on black velvet. Okay. But from there, we can also look at other parts of the Milky Way by looking at Sagittarius. Now, Sagittarius is about southeast tonight at around 10 p.m. It's moving farther to the south, and our best views are going to be in the south. But if you've got a dark sky, you can start picking it up right around 10 o'clock. So what we can see as well is that if we look over to the end of the teapot, the spout, off to the right, we'll find the galactic center. So that's the center of a galaxy right there, 26,000 light years away. Now that contains a supermassive black hole weighing in at about 4 million times the mass of our sun, and it's called Sagittarius A. So that's one little part of the sky to check out. If we want to go a bit farther, we can talk about some things called star clusters. Now, I love star clusters through the binoculars. And as a matter of fact, if you just pan that whole part of the sky, right from horizon right up through, and we're going to talk about some other areas up here that Paul's going to talk about, but my whole section of sky that I get to look at here, star clusters or groups of stars are here in big bundles. So not all star clusters are close to us, of course. In case of the small and large Sagittarius star clouds, and there's a small one up here, and it's called Messier 24. The large one, I don't know if it has a Messier number. Anyway, when we're peering through the small one, we're looking actually through the dust into the next spiral arm, because there's all kinds of dust and gas that's in here that's blocking our view. So the small Sagittarius star cloud is actually the most dense concentration of individual stars visible using binoculars, with around 1,000 stars visible within a single field of view. That's incredible. And there's nothing like, looking at the Milky Way is one thing, but bringing out your binoculars and taking a look, it just puts a whole new perspective on things. Now, the large Sagittarius star cloud is the brightest visible region of the Milky Way, and it's also the most distant part of the Milky Way you can see with your naked eye. So we're looking right in here, right around the lid of the, right on the spout of the teapot. So lots of star clouds through here. There's a couple other ones. There's a dark horse nebula. This is something called a prancing pony, which I'm going to bring up on the next couple of slides here shortly. So here's a sample view of what you might get through a pair of binoculars of the small Sagittarius star cloud. So look at the stars there, eh? Just incredible. And then this is the large Sagittarius star cloud. So there's more nebulosity in this area, more dark areas, dark nebula, more dust and gas, but is the brighter area that you can witness. And that's the farthest away we can see with our naked eye. There's something called a prancing pony. And a lot of us have talked about this. Paul, you've talked about this a lot. It's this dark patch that we see that looks like you turn your head sideways and it looks like a pony sitting here prancing along. So that's called the prancing pony. We see that down in around the large Sagittarius cloud, like right down in here. So if you get a better view of the Milky Way, you can pick it out a lot easier. But if you pick out that prancing pony nice like that, then you know you've got a really nice dark sky to enjoy.
Mm-hmm.
That's one of the ways to measure your dark sky, just by looking, not with a light quality meter, but that way. And the other one is to see if you can see all the stars in the Little Dipper. Now, that's star clouds. Another thing that's really my favorite is globular clusters. I love globular clusters. They're just amazing. They're big bundles of stars. So this is what's available through a medium-sized telescope in our summer part of our sky. Look at the number of them there. So they're the ones that I've got here outlined are about magnitude 7 or 8. There are a few that are magnitude 5 or 6. So the lower the number, the brighter they are. Magnitude 6 is naked eye. So you can pick them out, but binoculars are going to give you a little bit of a better view, like just a larger fuzzy ball, basically. But if you looked at them a little bit closer, you're looking at something like this. So globular clusters are huge collections of tens to hundreds of thousands of stars, all tightly bound together by gravity. Now, they contain some of the oldest stars in the universe. They're actually about 12 billion years old, most of them. So far, we have found about 160 of these clusters that orbit the center of the Milky Way. And so these are two typical ones, Messier 22 and Messier 4. These are ones that are visible through small telescopes easily. Messier 22 you're going to find right over here. They call that the Great Sagittarius Cluster. So very easy to find. There's the lid of the teapot and just off to the left. And if you go just above the lid of the teapot, you can find Messier 28. That's another one. Now that's not quite as bright as 22. If 22 was up higher, it would be the best globular cluster in the sky. But it's because it's down in this hazy part of the sky that it's not quite as bright, but it is still quite beautiful to see. If you come over to this side, we're into Scorpius. We see the antenna of Scorpius coming up here, and here's M4, which is right beside that reddish star here called Antares. So right next to that, just a binocular width over, you'll find M4, which is another globular cluster. And then you've got all these ones, and I put these on here that were right around the same brightness, maybe a little bit fainter, but certainly visible through medium-sized telescopes. So I'm saying something 4-inch telescope and up, you should be able to get some detail here. Binoculars, though, will give you, you will still get a view with binoculars through it. You'll see a fuzzy patch here, but you'll be so concentrating on the stars anyway. And of course, nebula. I don't know what these are. Paul knows a little bit about them, I guess, but when we talk about nebula, that's nebulosity. So nebula clouds are just clouds of dust and gas that are the birthplace of stars. That's how stars are formed, from big clouds of dust and gas. So some of the famous ones along here, here's the Milky Way center, as we pointed out a little earlier. We've got the Lagoon Nebula, which is called Messier 8, and there's that Sagittarius cluster. Then we have the Trifid Nebula, and then we have the Omega Nebula, and up farther up we have the Eagle Nebula. So nebula are again clouds of dust and gas. I'm going to go to the next slide and show you some. Here we are. So a nebula is an enormous cloud of dust and gas occupying the space between the stars and acting like a nursery for new stars. So we formed from one of these clouds. There are 4 types of nebula, basically: a planetary nebula, a dark nebula, an emission nebula, and a reflection nebula. So they're all visible. And you would need, I mean, you can pick out the witch head, I guess, with binoculars, Paul?
No, you never see that. It's
No?
too
Too dim? Okay. The ring, you would not be able to get that with binoculars, I don't think, either. The dark nebula, for sure, in around around Sagittarius area.
Yeah.
Where I was trying to talk about. So here's the M20, the Trifid Nebula. This is one of the nebula we talked about there. The Lagoon Nebula, M8. And this one is M8, the Trifid and Lagoon together, because they're not very far apart. And then M17, the Swan Nebula. That's a swan upside down, so that's the way it would appear through telescope. But you just have to flip up the image. I got that picture from St. Cypr's Beach with my 3-inch refractor and camera on it. So that's what we're looking at there. I'm going to end this slideshow. And I'll stop presenting. That's my little part.
So there's so much in that area to see.
Oh, yeah, that's just a small sample. And
Yeah.
you can spend like just an hour just panning up through that part of the sky, right?
Yeah, if you're fortunate enough to live on the south side of a city, so that you're looking south with
Yeah.
the city behind you,
Right.
and that's your view. That's the best part of the sky in the summer.
Yeah.
Yeah.
It really is.
No, Sagittarius is fascinating, and again, if you're just sitting back in a chair and you just have or just panning it, just looking at it with naked eye, but binoculars bring it out. That's just that much more. They're fairly inexpensive. They give you the right perspective. They're not too heavy to hold, and they're pretty portable, lightweight. So they really give you a nice perspective of that part of the sky. Once you start looking at that part in Sagittarius, just above it, and you find these star clouds, it's just like you get lost in the middle of it all. It overcomes you. It really does, fast.
Yeah.
Okay. What do you guys? What do you got?
You doing the middle section, Mike?
I thought you were going to do the middle, and I'll do the other end.
Okay. All right. Let me share my screen, and then I'll show you what I can show you. Entire screen, and it'll be this one. So I'm going to use Stellarium to show my little part of the sky that I think is interesting, and it's certainly my favorite part of the sky in the summer. So let me just see if I can get this to work properly. I'll turn this off.
Let me guess.
Well,
I wonder where he's talking about.
I don't know.
No.
So
I know that.
what I'm going to tell you about tonight is called the Summer Triangle, and the Summer Triangle is actually an asterism, or sort of like, yeah, I guess it is an asterism, of 3 alpha stars that make up a triangle. And what an alpha star is, of course, it's the brightest star in a constellation. Excuse me. And the 3 that we get our summer triangle with are Vega, which is very naked eye, very, very visible to the naked eye. And that is in the constellation Lyra. And then we move over to Deneb, which is in the constellation Cygnus. And then Altair, which is in, let me get my thing up here and I can show you actually. And that is in Aquila. So so when you look at that in this time of the year, because this is real time, the only reason you're seeing dark is because I got the daytime turned off. If you were to go outside right now, it would look like that. You're not going to see anything. So I'm just turning off my daytime so I can show you this. But as the night progresses, that'll get higher. And that's the nice thing about this time of year for this kind of a thing to look at, is it starts out in the eastern sky like everything else does, and it rises up over to the southern sky. So if we're looking at, let me just get my clock out here. There we go. So if we're just looking at some time moving on, you can see that now it's getting a little higher. So at about 11 o'clock, actually at 10 o'clock, it's going to be in a really nice position in the sky. So you'll be able to see Vega, Deneb, and Aquila. So this is standing naked eye. Now, how do you find this? Well, it's pretty straightforward. If you stand facing north on the ground and look up until you find, let me just put my constellation lines on. There we go. So look up till you find the Little Dipper, and that, of course, is the North Star. You're facing north. Then you're going to look to your right hand, to your right side, and you're going to look towards what we call northeast, which is right here. If you go a little further, then you're going to get into southeast. So between northeast and southeast, this is where Cygnus, Vega, and Altair, or Cygnus, Lyra, and Aquila, the 3 constellations are going to come up. So if you see, they're easy to see because Cygnus looks very much like a swan, and that's where it gets its name, Cygnus the swan. Lyra looks like a harp. So if you've ever seen a harp where they have all the little strings on it, that's kind of what it looks like there. Mike's got a Tim Hortons thing he talks about it. We'll get to that in a bit. And then, of course, Aquila, have a little sip, and it might be tequila. I don't know, but I'm not quite sure what that one looks like. But it's those are the 3 constellations that you'll find. Vega will be very, very small in relation to Deneb, and Aquila is about between the 2 of them. So if you look for those 3 very bright stars standing on the ground between northeast and southeast, pretty much the eastern sky, this time of the year, they're going to come up. At midnight, they should be pretty much getting to be almost overhead. So now I'm looking south. And the teapot, this is where this part of the sky that Chris just talked about. And the neat thing about all of these things is they all follow that Milky Way. So if you follow the Milky Way on up from where Chris has the teapot and the steam's coming up, which of course is our Milky Way, it'll take you right up to Aquila. Follow it up a little bit further. It'll take you right up to Cygnus, and just look off to the right a little bit, and then you're going to find Vega. So that would be the naked eye way to find these things. If you're going to use a pair of binoculars, you can get into the very tip of Cygnus the Swan, and there's a little double star there called Albireo. So if you get in deep enough with it, and I think you can see it with binoculars, Mike, maybe I'm not sure, but there's actually a double star. A small telescope certainly reveals it, and it's one of the most beautiful double stars you'll see because there's a nice blue star and a gold star right beside each other. And it's one of our favorite things to show when we're doing public observing or at star parties. Some of the more famous things in this portion of the sky, for example, in Vega, one of the things we like to show, if you have a telescope, you need not a giant one, but a telescope. There is, of course, the ring right here, and that is M57, and that is a planetary nebula. And it's a really cool thing to see. When you see it through a scope, it looks like a big smoke ring because you won't see the color like you do here. But it does look like a smoke ring. It's very distinctive. So that's one of the cool little targets.
Looks like a donut.
What's that?
Looks like a donut.
Looks like a donut, and that's all part of. I'll let Mike talk about that in a minute. The other thing that you can see here that you've probably seen a million times on any astronomy magazine or pictures, the North American Nebula, the Pelican Nebula is all here. You've got the Butterfly Nebula, you've got the Crescent Nebula. If you go down this part of Cygnus, you've got this wonderful complex where you've got the eastern, the western veil, Pickering's Triangle, and this is all a remnant of an exploded star some 8,000 years ago. And if you use an oxygen-3 filter and a fairly generous aperture telescope, like at least an 8-inch Schmidt Cassegrain, probably an 8-inch Schmidt. I wouldn't go much longer than that because you won't be able to see much. But anyway, you can see actually these structures extremely well. With that same O3 filter, if you go back up and look at the North American Nebula, you can see that as well. You'll want a wide field view, something around, say, a 480 to 600 millimeter focal length. And if you got like a 5 or 6 inch reflector, these are ideal with an oxygen-3 filter. You can see that just absolutely wonderfully. So that's basically what you're seeing in there. There's not a whole lot to see in Aquila, other than the fact that we've got the Alpha Star, and it is part of the marker for the summer triangle. But it is on that Milky Way journey right on up to Deneb, and of course right over to Lyra. Now I'm going to let Mike tell you about his coffee thing with Lyra. Let me just find Lyra here for you. There we are. Go ahead, Mike.
Well, it's just when we're at star parties and stuff, you like to chat with people, and they're talking about night sky, and somebody says, well, how did that get named what it was? You go back and say, well, back before we had lights and stuff like that, a bunch of people sat in the desert, looked up and said, that looks like a harp, right? And so they just named it I don't see a harp, but that's what they see, and they named it Lyra after the harp. I said, I think we should change the constellation names more to what, we are in today's society. So when I look up there, I look at, like you say, M57, we took a peek at that, and it looks like a smoke ring in space, or it looks like a donut. So, hey, you got a donut in space, and then you move up towards Vega, and just off from Vega is a double star, and then you find out, well, it's not a double star, it's a quad, which makes it a double-double. Well, if you got a double-double and a donut, why don't you call it the Tim Hortons constellation? Right? It only makes sense in today's
standard. They do resolve into double stars. They don't do on
Yeah. So I think Vega should have its official name changed to the Tim Hortons constellation because you got a donut and a double.
I like it. Done. I like it. Let's submit it. We'll put it into the IAUs.
It's every astronomer's favorite thing to have while they're out stargazing.
That's right. You got to use your imagination. Somebody way back when did and said that's a harp. So it even kind of looks like a coffee cup, right?
Yeah, that's right. If I type in summer triangle, let's see what happens. Okay, so it comes right up. So it automatically. So if you have stellarium, you can just type in that asterism, summer triangle, and it'll bring you right to it.
Yeah. Do you have an asterism button on yours, Paul? On your menu down below?
Oh, a sec. I would get that to pop up instead of all my other stuff. Where is it, Chris?
There should be one. If you have to actually configure it to have it, but you can put.
Okay, yeah, no, I didn't do that.
You can put an asterism button there to bring them on and off.
Okay. So anyway, so if you want to find out again, go outside when it starts to get dark, when you can start to see some stars. Find the North Star. It's one of the first stars that'll appear in the sky anyway. Find the North Star, and once you find that, look to your right, and then you're going to start to see in the eastern sky, you'll see Deneb and Lyra, and as it gets dark, you'll be able to see Altair, so you'll be able to see the summer triangle coming up in the east. Okay.
Awesome. Thanks, Paul.
Okay.
Yeah, that covers that part of the sky. Mike's going to take us to our other favorite part. I guess this is all of our favorite parts. I mean,
attempt to take us to that part. Alrighty. So continuing along through the Milky Way, if you started where Chris was, down at Sagittarius area, and you followed all the way up, and you come across Cygnus in the center of the Milky Way, and you kept on following the line all the way across the sky, you're inevitably going to end up looking up and seeing Pegasus and the big W of Cassiopeia and Perseus. And it comes right into there. I mean, the line goes right through. You can see it here. And there's so much stuff in this part of the sky. You know, the show's nowhere near long enough to even cover a portion of it. But saying that, we start with Cassiopeia. And you look up, and you can't miss it. It is either a big W or a big M in the sky, no matter how you look at it. You can flip and flop it any way you like. But there's one object that I found in there. It's both naked eye, but you got to be in dark sky. It's naked eye, and it's beautiful in you can see, it's not naked eye, but you can see it with binoculars, and it's beautiful in a telescope. And that is M13, the Owl Cluster, or as we call it, ET. So if we call it ET, we can also call it the Tim Hortons constellation, but that's okay. And it's also known as NGC 457. So it's the brightest open cluster in Cassiopeia and one of the finest objects of this type in the northern sky at magnitude plus 6.4. It's just beyond naked eye, but visibly seen with binoculars and beautiful in a telescope. And we do show people that a lot. As soon as they see it, you can't not recognize it. Yeah. The brightest stars in the cluster are arranged in prominent lines in the shape that resemble an owl, and that's where it's got its original name. So the popular name is the Owl Cluster, and it's located about 7,900 light years away. So that's just one object in Cassiopeia that I picked and said, you know something, if you're going to fire a small scope around or fire a pair of binoculars up into the Cassiopeia and look around, and again, there's so much stuff in there, but look for that little ET guy or the owl or whatever you want to call it, because it is a fascinating sight. Moving across, and now by the time this comes up, it's about 3 o'clock in the morning. So, it's not now and it's not early evening. It's late into the night, just before morning, when this is up nice and clear this time of year. As we move into the fall, it gets more prominent. But you can look up and see the big square of Pegasus, and it's easily recognizable. Now, most of us know how to take this corner here and follow 2 stars over and 2 stars up, and guess where it puts us? Right on the Andromeda Galaxy. And if you want a naked eye target, or a beautiful binocular target, or a small scope target, there's nothing better than M31. I mean, it's just incredible to look at. It's the closest galaxy to us, of course, and they say somewhere in the next, 4 billion years or something, it's going to collide with us. That'd be so cool to be around. Anyway, the Andromeda Galaxy, also known as Messier 31, was originally named the Andromeda Nebula, believe it or not. This is a barred spiral galaxy with a diameter of about 220,000 light years and approximately 2.5 million light years from Earth. But it's the nearest large galaxy to the Milky Way. So it's our partner, and it's going to collide with us. And I'll tell you, nothing better than to look at that puppy in a pair of binoculars, and real easy to pick out naked eye, actually, in dark skies.
Yep. Moving
on again, we come across Perseus. I don't know how you look at it. It looks like a little guy dancing in the sky to me. It's easily made out in this top area with, I think it's called Myrfik. It's the brightest star. Mm-hmm. And again, there is so much stuff around Perseus that you can share to look at in between Cassiopeia and Perseus. It's just unbelievable. But one of the objects is right in between the two. If you were following the Milky Way and drew a line through all those stars between Cassiopeia and Perseus, you come across the double cluster. And again, that is another one of our favorite targets to show people. Very easily seen with the naked eye, very easily seen with binoculars and a small scope. Visible in the naked eye from any dark location, Caldwell 14 is popularly known as the double cluster in Perseus. These two bright open clusters are called NGC 869 and NGC 884, appear side by side, about halfway between the bright stars in the constellations Perseus and Cassiopeia. Located about 7,500 light years away, the clusters contain hundreds of hot young stars. And they're running around a magnitude 5.3 to 6.1, so they're very easily seen. And I'll tell you, that's a heck of a sight in a pair of binoculars or a small scope. You look at it in a C8, and I don't catch the whole thing. It's that big.
Yeah.
So, but it was just, something that if you're moving your way through the Milky Way and you're up through Cassiopeia and Pegasus and Perseus, stop and take a good look at the double cluster, man. It's a gorgeous sight and real easy to spot. And something, if you're going to have fun, discover the night sky with binos, because that's the way to go when you're looking around. Yeah. I mean, telescopes are one thing, but binos are definitely the cup of tea that are going to show you some sights. So that's my little spiel.
Awesome, Mike. I mean, that's true, because you see a lot of astronomers now, like, we started out with binoculars and small scopes, and then they went to big scopes with F10, F12, F14.
And
they go back to this little tiny scope again, like guys who have had the experience with, like you guys, are back to the wide field views, and because you want to get that piece of sky around the object that you're trying to see, right? Same as you're trying to frame something, Paul, and you're trying to get the moon in the shot. You want to put some trees or whatever in the shot that helps to balance it. So your eyeballs get a better chance when they're looking at a bigger piece of sky to focus on that one area that you're really trying to look at instead of zooming in too much, I find. So yeah, binoculars are perfect for that. And again, they're reasonably cheap. I see sets up all the time on Marketplace on Facebook or different sites, Kijiji and stuff for $20. How can you go wrong?
Yeah.
As long as they're collimated and they're working well, they're very light and they're nice and easy to sit back in a chair and just pan those areas that we've talked about so far. So yeah, those are probably our top 9. Now there are lots of others, lots of others we show, but those are the ones we think that might be the easiest to pick out if you're out observing. So get out.
And by the way, all of mine are bino bud targets.
There you go. And mine probably were too, most of them. Yeah. Okay, that's great. All right. So that's a little bit of a review around, and Stefan says meteor showers. There you go, Stefan. That's another great one to be outside for. So if you're outside with the meteor showers anyway, they're hard to pick out with binoculars because, you can't really catch them fast enough. But if you're outside waiting for a meteor to come by, then sure, slap the binoculars up and take a look. Our best show this year is supposed to be the Perseids, but that's going to be a night of it's almost a full moon, I know, so it won't be a great show this year. But that's no excuse not to get out.
Right.
Okay, let's get on to our next topic then. If anybody has any comments on what their favorite targets are that we haven't covered, let us know. We'll shout them out here. Okay, so from there we're going to. How about we go to a Bino Bud next?
Bino Bud.
What's Bino Bud up to this week?
Have we covered Cygnus yet?
Too many times to count.
Cygnus. Like Marsha. Alrighty. Binocular target of the week should be coming up here. There we go.
There we go.
There's our buddy. So binocular target of the week this week by Bino Bud this is an interesting one, the home plate.
Yes, sir.
So believe it or not, that's exactly what it looks like. So this asterism field is located just west of M31, the Andromeda Galaxy, which we just talked about. It is very conspicuous in binoculars. With a binocular field of view of about 7.5 degrees, you can just barely put the whole home plate and M31 in the same field of view, believe it or not. How to find it in the sky? Well, like I said, we've all looked up and found the Great Square Pegasus. And to find Andromeda, you just go 1-2 stars over and 1-2 stars up. Well, you just shoot a little bit to the right from the Andromeda Galaxy, and guess what? You're going to find the home plate. Now, again, this is more a fall target, but at 2 a.m., which it's still dark here, or it just gets dark here right now, at about 70 degrees east-northeast, you look up and you will find it just to the right of the Andromeda Galaxy. what will you see? Basically, 1, 2, 3, 4. Look at that, shaped like a home plate, right? And that's exactly what you see when you put it in 10 by 50 binoculars. Look at that. And if you shifted this over to the right-hand side of your field of view, Andromeda would just touch on the left-hand side of your field of view. So it's a real nice and easy target to find. Size of the full moon, roughly, maybe just a little bit bigger than the full moon. So it's an easy target that stands out a bit against the background sky. Awesome. And a key moment in astronomical history, we've seen this one before. Cat's tail hits a scope, Galileo looks through, and woohoo!
That's how it happened. Okay.
So we're all blamed on the cat. And that's Binocular Target of the Week by Bino Bud.
Awesome. Thanks, Mike. Yeah, another timely target for sure.
That's great.
Yeah. I gotta go.
It is cool to look at, too. You look up, there it is. It's a baseball. The home plate. No other way to say it. It's home plate. It's pretty
Perfect
cool.
time of year.
Yeah.
Okay, how about Rosanna's Fun Facts next?
All right. Let's see if we can get that up and going. Well, see if I can make it so, number one.
Mike Thorne says, it looks like a mini Seafoods. Yes, it does.
There too, yeah. That's right.
Okay, so share the screen here. And if this is for another this week's
Rosanna's Fun Facts.
Well, welcome back, Rosanna, for another one of your wonderful fun facts. Thank you again for submitting this in here, and they are always interesting, as is this one. So let's get right into it. So NASA called, and they want their moon rocks and cockroaches back, please.
Okay.
Oh my goodness.
Yeah.
So according to Live Science, earlier this month, NASA contacted RR Auction, a Boston-based auction house, to stop the sale of the moon dust that was collected by astronauts during the 1969 Apollo mission. Now, shortly after the lunar dust was brought back to Earth, NASA sent some samples to a University of Minnesota researcher who experimented with feeding the moon dust to cockroaches to determine if the lunar rock contained any sort of pathogen that posed a threat to terrestrial life.
Wow.
Wow. In a letter dated June 15th, a lawyer for NASA stated that the samples, which included a vial of approximately 0.0014 ounce or 40 milligrams of dust from the moon that remains on the 3 cockroaches and dozens of microscope slides, still belong to the federal government. The motley collection of goods, which the auction house advertised as a one-of-a-kind Apollo rarity, was expected to fetch an impressive $400,000 at auction. NASA also fed some of the precious moon dust to cockroaches, dumped it in fish bowls, and injected mice with it as well. The astronauts were quarantined for 3 weeks upon their return from the moon. From the moon to determine any risk from the moon rock exposure. Confirming humans and mice would survive a chance lunar encounter wasn't enough, and keeping all other terrestrial life safe was a little more complicated than watching for coughs or rashes. One NASA document refers to trying to establish procedures as navigating a sea of ignorance, and emphasized that the authors couldn't predict how much moon rock the test they outlined would consume. In addition to the mice, the agency and its partners also selected other representative species: Japanese quail to represent birds, a couple of nondescript fish, brown shrimp and oysters for shellfish, German cockroaches and houseflies for creepy crawlies, and more. Lunar rock is precious stuff. The 6 Apollo missions to land on the moon collectively brought back almost 1/3 of a ton. The majority is locked away in a special government facility.
I know that scene.
The rest, incredibly tiny samples, were dispersed around the world in 1970 as gifts to various nations. But here is a little known fact. A staggering 2/3 of the gifted lunar samples are missing and presumed stolen. If others have desk drawers like this one, one of my friends, the samples may just be hiding in plain sight. Now, I've inserted 3 items into the desk drawer. Can you find the moon dust? Or maybe it's cocaine. I don't know. So let's have a look and see where they were. Next slide.
Oh, there's one, yeah.
Oh, okay. So she's got them all circled. So there's the first one.
Okay.
That's what she mentioned about, da 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 da. And then there's the second one. And of course, underneath that sticker is the third one. So there you are. So that is unbelievable. That's the 3 things in the drawer. So the Apollo missions are not the only source of lunar samples. A trio of sophisticated but little-known Soviet landers, let me just get to the next slide, there we go, are called Luna 16, 20, and 24, visited the moon between 1970 and 1976. Now here's a pic of a rather adorable Luna 16. Now each one managed to land, drill into the rock, extract samples, stow material, and ascent stage and fly home using a parachute landing. To quote Matt Brown, it was a remarkable achievement and would be tough even with today's technology. Even so, the 3 missions retrieved only about 300 grams of lunar material between them, and about 1/1000th of a quantity returned by Apollo. A third way lunar rock samples have made it to Earth would be as a meteorite. And it's, let's go back here. There we go. And maybe even a meteorite from Mars, like this one. Wow, eh? So then our last slide is, and there's Antarctica. And they're looking for, what do we got here, folks?
An argument. That looks like a moon rock. No, it's a Mars rock. No, it's a moon rock. No, it's a Mars rock.
Well, that's a really interesting fact. And that is this week's, come on.
Rosanna's Fun Fact.
Hey!
2/3 of the moon rocks are missing. That's
Wow,
crazy.
That's something, eh? Well, now.
No, it only cost $20 billion to go there, I guess. Give it away to everybody.
Yeah, let's not keep track of inventory.
Yeah. That's unreal to think
Yeah,
that
something
that
else,
much
isn't
is out there just going around. Yeah, it was 800 and some pounds, I think, of moon rock come back altogether.
Yeah,
Wow.
it's
I mean, there was a lot. Didn't they just open up a new capsule just a short while ago? I read that in the news, I thought, that there was a capsule that they had brought back that hadn't been opened. And I thought they just opened up recently. I'll have to look that up.
Something like, something along those lines,
Yeah.
New moon rock.
A new moon rock sample.
Yeah.
Chris Baldock says, everyone check behind your fridge. There might be
Probably dust bunnies for sure. Okay, how about we'll go with the what's up talk. I guess that's my turn.
What's up, Doc?
Hey, what's up,
What's
Doc?
up, Doc?
All right, let's have a quick look at what's up this week.
Next slide.
Next slide. Yep.
That was funny.
Okay, what's up this week? Not a whole lot. Let's take a look though. What we got? Well, I say not a whole lot. There's always something nice to look at, right?
Yeah, blood pressure.
I try not to.
Have a
Okay,
cookie.
so what's up this week? Well, we still have our Morning Planet show still going on. So it's the last couple of days, really, to catch all the naked eye planets together as Mercury gets very difficult to see now down close to the southeastern horizon just before sunrise. The bright sun is coming up just behind it. And of course, the sky brightens up a lot before the sun actually rises. So what's happening with Mercury, though, is it's heading towards the morning sunrise, and it's going to be into what we call superior conjunction, which means it'll place it on the opposite side of the sun from our point of view. Now, that means that Mercury's going to rise again in our evening sky a little bit later on. We'll talk about that after. The remaining morning planets will continue to spread farther apart, though, over the coming days and weeks. So they're still in the morning targets. And even into July, they're still morning targets. But we are going to get our first views of Saturn shortly in our evening sky. So though Mercury will disappear in our morning sky soon, it will show up again in the evening sky before the end of July. It only takes 88 days to go around the sun, right? So very little time behind the sun. Venus, the brightest planet now, will continue to get closer to the horizon as it heads for inferior conjunction, placing it between us and the sun on August the 13th. Now, it's not in the same plane as us, or else we would see a Venus passing in front of the sun. But it'll be between us and the sun on the 13th of August, so it's going to start heading towards the horizon as well. So Mars continues to brighten, though, and it gets even redder lately. Jupiter is the second brightest only to Venus, so it's very easily noticeable. High in the morning sky right now, and Saturn is probably the faintest one of the group, but it will brighten as it approaches opposition in August. And that's opposition means we have the Sun, Earth, and Saturn all lined up. So we're looking out towards the solar system, and Saturn is out there at its best when we're at our closest point to it. Okay, so Monday, tomorrow, Earth at aphelion. What's that mean? Well, it might be hard to grasp, but tomorrow we are at our farthest from the sun in our yearly orbit. That's because we orbit the sun in an elliptical path. Earth reaches aphelion tomorrow at 4:10 a.m. Atlantic Daylight Time, placing us about 152,098,455 kilometers from our star at exactly 4:10. And now in contrast, back in January 4th at 3:10 a.m. AD, we reach perihelion. We're our closest point to our star at 147,105,052 kilometers, or about 5 million kilometers closer. So we are closer to the sun in January. Now, on Wednesday, we have the Lunar X and Lunar V available. So when the moon's terminator, or that line between light and dark on the moon, is located in just the right place, you can see a letter X and a letter V on the moon. Now, I know you can spell L-O-V-E here somewhere too. I haven't quite seen all that, but there's the X and there's the V. Now, the Lunar X is a great example of how lighting and topography can combine on a planet or a moon to produce a pattern that seems familiar to the human eye. In reality, the illusion of Lunar X is created by sunlight falling on the rims and ridges between the craters Lacaille, Blanchisny, and Purbach. The V is caused by light illuminating crater Urquhart, along with several smaller craters. So it's quite nice quite neat to be able to see it. You have to pick it out at just the right time, though. Wednesday, July 6th. Thursday, we're into our first quarter moon. That's a cell phone shot with my telescope.
Really?
With a refractor.
Oh,
Yeah.
that's awesome.
Nice shot.
My old Samsung. Tonight our moon enters its first quarter phase when one half of the moon is illuminated, tonight being Thursday night. Some interesting facts about our first quarter moon from the website timeanddate.com. Now, moon phases are the same all over the world. The same percentage and area of the moon are illuminated no matter where on Earth you are. However, the moon is rotated in different ways depending on the time, the date, your location, and the moon's position in the sky. Therefore, the illuminated part can be either on the left, the right, the top, or the bottom. At the first quarter in the northern hemisphere, the right half of the moon is lit up, while the left half of the moon is illuminated in the southern hemisphere. Now, near the equator, the upper part is bright after moonrise, and the lower part is bright before moonset. Pretty cool. We're all looking at the same moon, though. That's cool. That's even cooler. All right. Also on Thursday, we've got the chance to view the straight wall, and the straight wall is just at about day 8 of the moon's orbit, and we're almost day 8 there. Rupus recta, or lunar straight wall, casts a wide shadow that gives the appearance of a steep cliff right here. Kind of looks like a sword too. Now, the fault has a length of about 110 kilometers long, a typical width of about 2 to 3 kilometers wide here, and a height of about 240 meters. So although it appears to be a vertical cliff in the lunar surface, in actuality, the grade of the slope is relatively shallow. So you wouldn't really feel like you're actually on a cliff for sure. You just feel like you're walking down a slope, basically, if you're on the moon. Or bouncing down the slope, I guess, from the moon. Now, this is the view from the first quarter moon, but if you look at it from the third quarter moon, this is going to be not visible because the sun is shining from this angle, right? So we're not going to have that sharp edge like that. So it's available in the first quarter moon, just after first quarter. Now the evening planets return. Hey, here we go. Finally get a chance to see return of the evening planets. Now Saturn is the first naked eye planet to reappear, rising by 11 p.m. next Saturday, and followed by Jupiter at 12:39 a.m. So they're both getting closer. They will each rise about 4 minutes earlier each night. So you'll have lots of time for observing them right into the fall this year, when the evenings are cool outside and you're not dealing with so much moisture, no bugs, and here you got Jupiter and Saturn in prime position. Saturn doesn't get to opposition until August, so instead of September, we'll still have a nice sky with it. Now Sunday, the moon and Antares are together. Next Sunday evening, look for the waxing gibbous moon as it visits the red giant star Antares in Scorpius. Now Antares lies about 500 light years away, and it's nearing the end of its life. Antares is reddish in color and much cooler than many other stars. Now its surface temperature is about 3,400 degrees Celsius compared to our sun's surface temperature of about 5,800 degrees Celsius. That's why the color change. Now, if you could place our sun and Antares side by side, you'd find Antares more than 10,000 times brighter than our sun and about 700 times the sun's diameter. Wow.
Wow.
So it's big. So that's next Sunday night. It's always something to look at for sure. Now, Lisa's Lookup, speaking about to look at, you want to find out what to look at, take a look at Lisa's page. Lisa's Lookup, Astronomy and More. You can find Lisa at Ruby Moonbeams on Instagram, Twitter, and Facebook. Lisa puts out this excellent chart every month. She lists the events down here on the left, then she puts the dates, and then she puts the times that are best to watch it. And then she includes naked eye, binoculars, or telescope, which what you need to observe that object. So again, Lisa's Lookup, Ruby Moonbeams on Instagram, Twitter, and Facebook. And we have our own local club as well, of course, the St. John Astronomy Club, sjastronomy.ca, and we are also members of the Royal Astronomical Society of Canada, the New Brunswick chapter. So that's at rasknb.ca. So both these websites are up. Lots of information on them. And here's our calendar for June, July. So we're getting into the end of July. There's a new one out now for July and August. I haven't put it on here yet, but I'll have that up next week. So that's about what we have to look forward to anyway in the next week.
Wow, that's a big thing.
That's a big story.
Isn't it?
We're insignificant.
We are. Very much so. Okay, how about Astro Tip of the Week? Hey,
All right.
you, Paul.
Okay. What I'm going to be talking about this week is I was actually saw some people having a conversation about solar filters, and this is the time of the year, and this is the time of our decade that we're actually getting back into a very active sun, and so everybody's interested in looking at it and taking photographs of it and what's safe and what's not safe and all that kind of stuff, and then some discussion was going on about what can you actually see with what filter. So I'm going to talk a little bit about that, and so everybody knows when they go out what it is that they can see with what filter that they're looking at, and what is right and what is not right to use. And I'll go through it relatively quickly. So let's go to our first screen here. Okay, so basically I snapped this picture out of a magazine because it was the most perfect thing that I could use to describe what it is, first of all, that you're looking for in terms of features, and what it is that a white light filter will show you, and what it is that a hydrogen alpha telescope will show you. So if you look at the right side, for example, when we take our simple solar paper, put it over our telescopes, and go sit outside and either observe or image, using, of course, the observing paper, so you can do both. With the white light filter, you're able to see sunspots, you're able to see facula, and you're also able to see, and I'll make this a little bigger so you can actually see it. You're able to see granulation. You'll also notice with the white light filter, the edges are always darker than the center, and that's called limb darkening. And that's actually something that happens because when you're looking at that portion of the sun at that angle, there's actually a shift in temperature, and that's why it actually gets a little bit darker there. But that limb darkening allows you to see that facula very well. So the best place to catch that facula will be right in and around the limb of the sun. The sunspots, of course, they're self-explanatory as what they are. And of course, the granulation is that fine stuff that you see right down in there. That's what you'll see with a white light filter. When you're using a hydrogen alpha filter, first of all, you're concentrating the light into a very, very thin, specific light, narrow band of light, 656 nanometers, 0.28 to be exact. And so that's the hydrogen alpha area that you're looking for. So when you're looking into for hydrogen alpha, you're going to be looking into the chromosphere. In the chromosphere, when you're looking at hydrogen alpha, what you're going to see, if you're using the correct scope for this, you should be able to see some active regions, which will look a lot like these little white areas that you see in and about here. You should see some what they call specules. If your sky is really steady, the sky's going to be really steady to see this. But what the specules are is, you get closer into this. I'll see if I can get closer, if I can show you. The specules are those little tiny little, almost looks like little radioactive points on a Richter scale, I guess, a Richter scale kind of a thing. And what that is, that's just very, very, very small parts of the thing. So the edge of the sun's disk seems to have thin skin running around it. And this is a cross section of the chromosphere. Under good seeing, you can make out that it is made up of tiny jets known as specules. And together they make up the edge of the sun that appears furry. Also, you can see prominences and you can see filaments. Now, prominences and filaments are the same thing, but a prominence is looking at it edgewise, and they'll jump out like you see right here. And a filament would be these ones right here. It's the same thing, but we're looking at them face on into the chromosphere. So those are the things that you'll see with a hydrogen alpha filter or telescope, the proper telescope. Now let's move on to the important stuff. And this was the part I want to kind of make sure that everybody understands. I'm going to shrink this for a minute. Some people think, well, I'll use my H alpha filter that I just bought to get my nebula that I want to see, and I'll put that in my telescope or on my camera, and I'll be able to focus and shoot the sun with my H alpha filter. Is it not going to protect me? No. And the reason it won't is because it still allows all that energy to go through that filter. There's no energy rejection whatsoever in a filter that's designed to shoot nighttime photographs. Now, let me explain to you how that works so that for anybody who's wondering about this, that there won't be any question as to what this is. So let's have a look at these two diagrams. So first of all, here is the Coronado PST telescope, and it's broken down into pieces and parts. And here is the light that will come through it, going through the certain parts of the telescope. And I'll go through it really quickly because it's quite simple. On the very beginning of the telescope, why the very end of the telescope is red is because that is where the energy rejection starts to take place. That's where it starts to narrow down the light that's going into that telescope, and it starts to reduce it. So right here on this diagram, and I'm talking about this part of the scope, the light will go in here, and then it goes and it goes into what they call the etalon. The etalon is where it actually gets even more focused into a very specific kind of light. And there are two plates in there that basically that you tune if you're using a Lunt scope. It's called pressure tuning. You squeeze this little thing that makes the plates, either they just kind of move in relation to each other at a very specific length, so you don't lose the actual light. But anyway, and that's where that takes place. But even at the etalon, where it's focusing in on that 656 nanometers, it's still a lot of stray light that gets through that. So when and then when it does, it goes back into this place here, into the telescope. And this is where you have to have what they call a blocking filter. And what a blocking filter does, it takes out that stray light that you don't want and only allows the light that you want to view or observe or image through the scope and up into your eyepiece or into your sensor if you're actually imaging it. So that's basically how that works. So when you're tuning your telescope, and what I mean by tuning is if you're turning that pressure switch on a lunt, or if you're spinning that little band on a PST telescope, all you're doing is you're altering those plates. And the reason you want to do that is because you may want to have a little bit more of a look at the prominences part of the sun, or you may want to look more into the center and onto the surface of the sun. And that's basically what that thing lets you do, is to choose between what part of the sun that you want to look at. And that's why it has the etalon that's adjustable. So basically, now that when you look at this diagram here on the side, it will all make sense. So if you go through the front of the telescope, the red part at the very beginning of the telescope, that is the energy rejections part of it. It goes to the etalon, which is actually narrowing down the band of light that you want to see and focus on. Once it goes through there, then you're going to go through your blocking filter to take away the stray light that still can be harmful, and you want to focus specifically on the light, which is the hydrogen alpha, 656 nanometers of light. And that's how that type of a telescope works. And a lot of that is designed because of accuracy, contrast, all that stuff. But the main thing to keep it safe is that rejection, energy rejection, and the blocking filter. And that's what keeps it safe. None of this stuff is in a hydrogen alpha filter you buy to look at a nebula. So I really want to explain that so people understand that you can't just take an H alpha nebula filter and start imaging with it. And so basically, those are the three things: H alpha, and there's one there we didn't talk about, which I won't talk about today, calcium, and of course, the beta white light filter. And those are the three ways that you look at the sun. So that is my Astro Tip of the week. Get the right filter for the right job and be safe.
Awesome, Paul. Good points. Good tips, pal.
Absolutely.
Yep. And be safe. That's a big one right there for sure.
Yeah.
The sun's a fascinating object right now, and we're like you say, we're coming up into solar maximum, so we're getting a lot of activity right now. I just I keep getting alerts on my phone, and I've got an app here that keeps telling me about the KP level is increasing. When it gets to KP of 4, it sends out. It's been sending them out most of the day. There's a big coronal hole right now that's facing us right now on the sun, so the solar wind is escaping more through that coronal hole area. Not a sunspot, but just an area where it's kind of stripped back a bit. And that's causing some energy, I guess, in our atmosphere right now. So they're looking at KP4, maybe KP5 tonight. So,
Wow.
yeah, I mean, we're at this time of year too. I mean, it'd have to be 3 o'clock in the morning for you to get a chance to see it.
Yeah, exactly.
Sun doesn't go down like midnight. Not a good time of year for observing. Well, really, but we'll get by. The days are getting shorter now. Okay, let's get to our photos, I guess, next. And I just need to bring up a couple of things here. And I'm going to share screen. Okay, we don't have too many photos here tonight, but we got a few, so we'll bring them up. We're always happy to get them. I'm going to start out with this one from Brad Perry.
Oh, very nice.
Yeah.
Touching water. Wow.
Yeah,
nice
nice, huh? So Brad says, hi, Chris. Here's a photo of the Milky Way I took from the causeway in Mactaquac on Tuesday night, just after midnight. Well done, yeah.
Beautiful.
There's that prancing pony.
It is. There it is, right there. There's the prancing pony. We'll zoom in a little bit. There, we can see it now, nice and clear. He says it was the night of the new moon, and every forecast model agreed on a clear sky. So I took it as an opportunity to go for a drive and try out a different location for a change. Also, as it pertains to Paul's astrophoto talk from last week, I thought I'd point out that this was with a crop sensor camera and the kit lens. It can be done, he says.
Oh, yeah.
There you
Awesome.
go.
Very nice.
Well done, Brad. Thanks for that.
Great. Good job.
Shelley Armstrong sent this one in from last week. I didn't get a chance to capture, but I'm glad I get it now anyway. So this is we were talking about those double rainbows that we were seeing over the city. Just a
beautiful.
while ago. I was out taking some sunset photos tonight and captured a beautiful double rainbow display before it completely disappeared. So yeah, that's pretty cool.
Look how it's reflecting off the water as well.
Yeah.
That's
Completing the circle.
Yeah, just about.
That is
If it wasn't for that flat Earth, you'd probably get a whole circle.
Well done.
Thank you for that, Shelley. Okay, Frank Ferguson. So Frank says, thanks for the reminder of the ideal viewing of the Milky Way, Chris. He said it's been way too long since I've spent some time under the stars, but was again blown away. Look at that. You sure were.
Yeah.
Wow, look at that. Beautiful capture.
Looks like
Should
green.
blow you away.
Looks like green down there in the horizon, doesn't it?
It does, yeah.
I wonder if we get some aurora down there.
No, that'd be to the south.
Oh, that's south. That's right. Yeah, it would be. Yeah, it wouldn't get southern aurora, not from this point. But hey, look at that prancing pony straight out there.
There it is again, yeah.
Yeah.
There's Antares.
And there's Ontario.
Yeah. Nice and bright.
Yeah, great shot. Thanks, Frank. Good to see that you're out under the sky again. You're enjoying it. Got these from Duckman, Harsno. Duckman says 3 planets at 4:10 a.m. on June 29th. There we go.
Yes, sir. Mars, Jupiter, and Saturn?
I'd say, yeah.
Yeah.
And he said in Jupiter with some moons. There we go.
Yes, sir. There you go.
He says a bit jittery because I didn't have my tripod handy, but looks great.
Yeah.
Thank you, sir.
Yeah.
These were from last week too. I got them just before our show started last week, so I didn't get a chance to show them. But this is from Ian. Ian Bloom from Aussie,
Ozyland.
from the Southern Skies. Hi guys, he says dismal skies here. So here's a couple of images of the Trifid Nebula. The first is the image is after stacking its equator. Final image after processing raw therapy. I've only got the one I think in here tonight, so this is the one. But
Good
nicely
shot.
done.
Very nice.
Good stuff, Ian. Thanks for sending that in. Love to see the skies from down under.
Mm.
Oh, and here we go. This is from Lisa. Lisa Ann
There's a
Fanning.
moon up
Says,
there.
hi, Chris. She said, sending a double moon love from the Jersey Shore.
There you go.
There you go, 2 moons.
Awesome.
Yeah, the real 7% waxing crescent moon from Friday night and the moon on the funhouse. Wishing everyone good vibes and clear skies, she says.
Well
Awesome.
done.
Thanks,
That's
Lisa.
terrific.
Right after that, we got Rob Fanning's picture here. He says, hi, Chris. I took this moonshot, 7% waxing crescent, at the boardwalk in Point Pleasant on Friday evening. Not nice.
That was nice.
Right,
Beautiful.
right spot.
Yeah.
Thanks, Rob.
That's cool.
Matthew Dupre sent this one in. Matthew says, here's my submission for the week. This week, it's of Ro Ophiuchus.
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 Ophiuchus, okay.
Ophiuchi.
So everybody's seen these, okay, yeah. And it's about 23 minutes total exposure time. It was stacked in Deep Sky Stacker and edited in Photoshop. And the equipment I used, a modified Canon T3 and a 50mm lens on the Star Tracker. Isn't that cool?
Wow.
Well
Well
done.
done.
Wow, nice.
Look at the dark dust lines, man. That's crazy.
Yeah. Just, oh,
Beautiful colors.
An M4 standing right out. That's
Yep.
real nice.
Awesome.
look at the stuff around here. Yeah, it's crazy. Awesome. Thanks, Matthew. Oh, and he sent this one in too. This is kind of neat. I thought you might
I
like
love that
some
shot.
might
Wow.
like some weather action shots. So look at that.
I've been just dying to get
Yeah.
something like that.
Look, you even got it down here near the horizon.
I can't even get hit by lightning, let alone get a picture of it.
You haven't got a long enough telescope, Mike.
No, I guess not.
By
Look
putting
at
the antenna on.
Right down on the horizon.
I'd be
too.
the guy holding the umbrella higher, right?
Yeah. What a great shot. Thanks, Matthew,
Beautiful.
for that.
That's fantastic.
Carol Bean sent this one. Carol always takes some beautiful shots. This is tonight's moon. She said among the trees. That was 2 nights ago. Yeah.
Beautiful.
So
Hmm.
she caught that nicely.
Nicely framed.
Thank you, Carol. And finally, I'm going to follow up with this one here from Kevin Clover. Kevin says, hi, Chris. He says, following topic to Mike's meteorites dash asteroid belt, not to be confused with Astro's belt.
Yeah. Astro belt.
There we go. Yeah, that's awesome. And okay, so I want to thank everybody for those. They were great. And if you'd like to send in your photos, we love getting them here. We love showing them off for you. And we love just getting them at all. I mean, we've had such bad nights. I know we haven't got many photos, but clear nights are coming. So you can send them into SundayNightAstronomyShow@gmail.com or send them into SNAS@astronomybythebay.ca. And we'd be happy to include them on our next program.
Absolutely.
You betcha. Okay. Well, I guess our time, gentlemen, please, right?
It is.
It is, yeah. So let me get back to our full screen here before we sign out. There we go. That's better. Okay, so in closing then tonight, we'd like to thank all of you again for your continued support. Also like to thank Rosanna, of course, once again for another interesting fun fact segment. That was really cool. 2/3 of the moon rocks gone. Eek. That's not good. Thank you, Rosanna. We always appreciate your contribution to the program, and we also hope that those of you who have joined us from the Rogers Network enjoy the program tonight. If you would like more information on the wonders of the night sky, you can find me at astronomybythebay.ca. Now, thank you as well to all of our followers here on YouTube and Facebook and Instagram channels as well, who continue to share our broadcast with your family and friends, like the NB Storm Weather Center, our friend Sean out there, Trudy, of course, and Brad, and everybody out there who's been sharing our program. We really do appreciate it. Remember, too, we do love getting your photos, so you can send them into SNAS at astronomybythebay.ca or Sunday Night Astronomy Show at gmail.com, or put them on my page, Facebook page. I can pick them up there, too. And we'd be happy to include them in our next broadcast. Now, we're also looking for suggestions for topics for future shows. Got a couple ideas that we might be talking about soon, but please send them into the same address. We're always looking for ideas. This is a teaching program, so we'd like to offer our bit of knowledge, a little bit that we have, to all of you if you're interested in taking it. So just pick up a topic, and we'd like to do a show on those, so let us know. And please let your friends and family know as well that we are here every Sunday night at 8 p.m. on YouTube and Facebook to edutain you on astronomy and the wonders of the night sky. So for now then, from Mike and Paul and I, wish you all a safe and happy week. Lots and lots of clear skies out there, and as we like to say, open your eyes to view the skies, and keep your scopes pointed up.
Point it up.
There we go. Good night, everyone. Thank you for joining us.